What does a statistical consultant actually do all day? Most people picture someone buried in numbers, but the reality is far more dynamic, client-focused, and intellectually rich than you might expect. At 3D Statistical Learning, this is our world. Let's walk through it together. The day begins early. The first task, analyzing data for a client. This isn't just running a few lines of code. It starts with understanding the question. What is the client trying to learn? Are they running a clinical trial, a business experiment, or an academic study? The data comes in many forms: structured, messy, incomplete, large scale. Before any model is run, the data must be cleaned, validated, and explored. We check for missing values, identify outliers, examine distributions, and assess whether the data actually supports the question being asked. We ask, is this a cross-sectional study or longitudinal? Are the measurements reliable? Is there potential for selection bias? Then comes the analysis itself. Depending on the context, we may run descriptive statistics, fit regression models, apply survival analysis, or use mixed effects models for repeated measures. Every step is documented. Reproducibility is not optional. It is a professional obligation. We use tools like R, Python, and SAS, and we annotate every decision. Why this model? Why these covariates? Why this transformation? The output is not just a number. It is an insight backed by rigorous methodology. By mid-morning, it is time to meet with another client to discuss statistical models. This is one of the most important and most misunderstood parts of consulting. Clients often arrive with a vague question. It is our job to translate that question into a precise statistical framework. What is the outcome variable? What are the predictors? Is the relationship expected to be linear? Are there interactions? Are there confounders? We walk the client through their options. A simple linear regression may suffice. Or perhaps they need a logistic regression for a binary outcome, a Poisson model for count data, or a Cox proportional hazards model for time-to-event data. Each choice carries assumptions. Each assumption must be tested. We explain the trade-offs in plain language, not to oversimplify, but to empower the client to make informed decisions about their own research. Communication is a core skill in this profession. A brilliant analysis explained poorly is a failed analysis. We also discuss what the model will and will not tell them. Statistical models describe associations. They do not prove causation unless designed to do so. We set expectations clearly, early, and honestly. In the afternoon, the focus shifts to writing. Writing up a report on findings is where science meets communication. A good statistical report is structured, precise, and transparent. It begins with a clear statement of the research question, the study design, and the analytic plan. It describes the population, the variables, the sample size justification, and the statistical methods used, including the software, version, and any packages. The results section presents effect sizes, not just p-values. A confidence interval tells a richer story than a single threshold. We report what was significant, what was not, and we do not hide inconvenient findings. Every table is labeled, every figure is captioned, and every abbreviation is defined. The interpretation section connects the numbers back to the research question, discussing clinical or practical significance alongside statistical significance. We also flag limitations honestly. Was the sample size sufficient? Were there missing data? Were key assumptions met? Transparency in reporting is what separates rigorous science from selective storytelling. It is what builds long-term credibility for the researcher, for the journal, and for the field. To end the day, we conduct a training session. This is perhaps the most rewarding part of the work. Teaching statistical concepts to researchers, analysts, and clients is how we create lasting impact. In a typical session, we might cover the logic of hypothesis testing, the correct interpretation of a p-value, or the difference between statistical and practical significance. We address common misconceptions, like the belief that a non-significant result means no effect, or that a large sample automatically guarantees valid conclusions. We use real examples, interactive exercises, and case studies drawn from actual research. Participants leave not just with knowledge, but with the confidence to apply it. That is the mission of 3D statistical learning. Not just to do the analysis, but to build statistical capacity in the people and organizations we serve. Every day looks a little different. Some days it is a complex mixed model. Some days it is a struggling PhD student who finally understands their data. Some days it is a client who trusted us to guide a high-stakes regulatory submission. But the thread running through every task is the same: rigor, transparency, and a genuine commitment to evidence-based decision-making. 3D statistical learning: rigorous, evidence-based, trusted.